Hello everyone, how are you doing? It's Aneta Stepankova, an event coordinator at STRV, and I would like to welcome you all here at our already 5th STRV online event in 2021. I'm happy that there is a really great show up, and I hope that you will enjoy the talk without any major technical issues. In the beginning, I just want to cover a few basic rules so everything can run smoothly. As a participant, you have a number of possibilities how to interact with a speaker or even with other attendees. We would like to encourage that so your experience is as lifelike as possible. Firstly, you have an option to raise your hand. This will be our priority. Every time anyone raises their hand, virtually of course, we will step in, call you up, unmute you, and you can ask the speaker directly. Another possibility is to write down the question in the Q&A section. In that case, we will get to your question after the presentation. And also you can chat with us and other participants in the chat section. There is an option for who you want to address your message. So always make sure that you are writing to the right person or group of people. Okay, that's basically it from my side. Now I just want to do a quick introduction. Firstly, let me introduce our speaker, Petr Sevcik, iOS developer, and also Jan Pacek, an iOS platform lead, to whom I would like to give a word right now. That's all from me. Thank you and enjoy.
Thank you, Annette, for the introduction. It's a pleasure to be here. And today we have Petr. He's one of our iOS engineers. He's been working for a long time on one of our projects, Live Penalty, where he came across a lot of animations and animation challenges. So he's gonna share with us today his experience. So Petr, please take it away, and I'll be monitoring the chat and Q&A. And try to answer any possible questions, and the rest we can do a Q&A session after the talk.
Thank you, Honzo. I will just share my screen. Okay, I hope everybody can see right now, right?
Yeah.
Okay. So, hi, my name is Peter, and I would like to talk to you today about my work here at STRV and on project Live Penalty. And the journey begins roughly 2 years ago when we started to build the app from scratch, and it has been really fun to watch it grow from like a drawing on a blackboard to a real application in App Store. And Live Penalty is a bit unusual in the world of application because it's a game and the concept of the game is kind of specific. So I would like to talk to you about it first. Now, let's imagine there is a big room somewhere, like a big hall. And in this room, there is this football goal. And in front of the goal, there is a live person, a real life goalkeeper. And in front of the goalkeeper, there is a custom built machine which is capable of shooting balls at the goal. And in front of the machine, there is a camera which records all of this and streams it to the application. And what we do on the client side as developers, we create all sorts of visual elements, animations, and stuff like that, which turns it into a game. So in the end, you get something like this, which is a mix of real-life video with game elements from application. And it's a multiplayer game, which is based on real time events. So let's say at Thursday 7 p.m. there is a live shooting with some goalkeeper and 100 players join the game, and all of these players play together through game against each other and against the goalkeeper. So through the game they each choose a position in the goal where they want to shoot the ball, and their targets get sent to our backend, and we calculate from all these targets like a final position for the machine. We send the position to the machine and the machine shoots at the goalkeeper. Now, based on the result, whether goalkeeper saves it or it's a goal, player get points, they get scored, they can get into leaderboards, and so on and so forth. And this is the original phase of the application, the original idea. And Life Penalty kind of started to turn some head around. It got some funding, it got some investors, it won some prizes, but it's still not where it kind of needs to be yet. So we are developing still new features, and we are trying new game styles, and what works we keep, what doesn't work we toss away. And the app kind of changes and evolves really dramatically, which is challenging, but many times also fun and source of wisdom. And these days, we are kind of moving further away from the real game event-based idea, but it's starting to get more playable and more enjoyable. So what do we do as iOS developers? Here is that on one side, we are creating this regular application, which has like user profile, and you have your sign-in options, you have tables with cells. And on the other hand, there's a game with complex game logic and streaming of the video and these game elements and animation and visual stuff. So that's what I would like to talk to you about, how we deliver these visual features, what kind of challenges it brings, and what have I learned. So when a specification for a new visual feature arrives, it usually looks something like this. And straight away, you can see that these are not everyday views, right? This is not something that you can drag and drop into the storyboard. Mostly these are game elements, more complex visual objects that we have to create from the scratch in the app so we can have full power over them. And drawing these first statically is sometimes much more challenging than the animation which comes afterwards. I would like to talk to you about drawing them first. And this is where we meet our key player or core player, which is CoreAnimation. And CoreAnimation is a framework whose job is to compose different pieces of visual content on the screen as fast as possible. It is considered to be a high efficiency rendering because it uses GPU for the rendering, as opposed to if you were to use core graphics for rendering, you would be using CPU bound operations, which can get a bit slower on all the devices. And actually, it was created back in the day when Apple first came up with iPhones, and they faced a challenge. They had to come up with fast user interface on devices which were far behind laptops and PCs in terms of graphical performance. So they came up with CoreAnimation, which helped to do this. And it actually debuted on Mac, where it provided some optional way of rendering stuff, but on iOS, it has been a key part from the very beginning. All of the visual content that you see in your views, all of the transitioning from one view to another, that's secretly powered by CoreAnimation under the hood, even without you as a developer touching you explicitly. And where do we actually touch it? How do we get in contact with CoreAnimation? In UI view, which is a rectangular object for displaying visual content, there is a property which is called layer. And this is an object of type CALayer or CoreAnimation layer. And its property who is responsible for all the rendering and all the animation in the view. And view is just a wrapper which comes around this layer and brings some extra functionality into the game, like auto layout, gesture recognizing, and so on and so forth. And there is a reason why these two are separated, and that's because CoreAnimation, it is great at the graphic thing, at the rendering stuff, and that's something which is needed on iOS, on Mac, on iPad. However, on Mac, you would have totally different user interface paradigm, right? You wouldn't use your touches, instead you would use mouse. But so on Mac, you could use Mac-specific NS View and use CoreAnimation to do the rendering. And on iOS, you could use iOS-specific UI view, which uses CoreAnimation for rendering. And of course, UI view gives you some options how to customize the content, right? You can use UI view APIs directly to change like background color or alpha, or you can animate something by typing UI view.animate with duration. But all of this is UI view accessing CoreAnimation layer for you, so you don't have to worry about it. Now, when we access, if we access CoreAnimation layer directly, the API directly, we have much more power and flexibility. And that's what we are doing all the time. So now I'd like to demonstrate how I would approach, like a general approach I would take when creating something like this, which is like this big gradient donut. And this is how it looks like when it's static. And once we start to animate it, it will look like this. So the gradient will slowly start to animate in clockwise direction, which reveals this other gray donut which is underneath. So we are creating sort of a timer. Okay, so first of all, I would start by declaring a custom UI view class, which will be called timer view, since we are building timer. And there is not much in it so far, only my custom designated initializer, and I'm setting the background color. Now, in some controller, I will lazily initialize this object, timer view, and I will add it to layout and manage size and position with auto layout as I would do with any other view. And now it's time to, this is the result after what we get. So a gray square in the middle of the nowhere. And we need to start adding our sublayers. We need to achieve something like this. And so when we start to build visual content with CoreAnimation, the way to go is to actually add additional sublayers to the root layer of our view. And all of these sublayers are child classes of CA layer. And each child class type is optimized to do different thing. So for each sublayer that we will add, we will follow this approach. First, we will initialize and configure the sublayer. We will add it to layout. And finally, we will manage size and position. So first sublayer will be CA shape layer. And this is a child class of CA layer, which is optimized to draw geometrical shapes, and it's very fast. So I will lazily initialize this object, which will be called lower circle layer, because it's at the bottom of our visual hierarchy. So here I'm initializing it, and I'm also setting some properties, which is fill color, stroke color, and line width. And these are associated with the shape that we're going to see later on. And if the shape were a triangle, then the fill color would be inside, the stroke color would be the color of the outline, and the line width would be the width of the outline. And since we want a donut, I've set the fill color to be clear, because we don't want nothing inside, basically. So that's the step one. We initialize, we set our sublayer. Then we add it to layout. And we need to do this only once, and a great place to do this is actually during the initialization. So here in init, I'm calling setupLayout method, in which I'm adding lower circle layer as a sublayer to the root layer of our view. Now the third step, now it gets a bit tricky, because we need to manage size and position. And we cannot really use auto layout here as we would when working with views. Instead, it's a common practice to use and to work with bounds and positions directly. And great place to do this is layout is a lifecycle method of UI view layout subviews. So, and for reasons, first of all, bounds of view are properly set at this moment, and we need those bounds to be properly set because we are using them to position our sublayer. And also, now the sublayer will always take the size of the UI view into consideration, meaning that if UI view gets bigger, layer gets bigger. So here I'm setting the frame of the lower circle layer to be equal to the bounds of my view, so it fills the whole bounds of our view. So just to recap, this is our timer view. Here I am initializing my CA shape layer. I'm adding it to layout, and I'm managing size and position in layout subviews. And I also added a background color to be green. So now we can see it, that it fills the whole bounds of the view. The next step would be, we really need to, we don't see any shape, right? And we want to see the donut shape. And in order to see the donut shape, we need to define that shape by populating the path property on CA shape layer. And this property accepts an object of type CoreCG path, which is a core graphic representation of the UI Bezier path. And UI Bezier path, you can think of as a chronological order of drawing instructions. And you can set these instructions either manually, right? You can say, start drawing at some point and then move to some other point, or you can use one of the helper methods that UI Bezier path provides you. And that's what we are going to do. So I'm creating this method make arc path because circle in the world of iOS is often called arc. And from this method, we will return the object of type CG path. So here I'm using one of the helper methods of UI Bezier path just to create the arc. And we need to fill in some parameters. We will start with arc center, which is the center of our circle, which comes from outside of the method. So we start somewhere in the space and time. And then we need to set the start angle. And angles in iOS relates to point like this. We want to start at the 12 o'clock. So I will set start angle to be 3p12. I'm also setting radius, which is a constant of 150. And finally, I'm going to set end angle to be start angle minus 360 degrees. So we start at 12 o'clock, we go minus 360 degrees, and we are back at 12 o'clock. This is the path of our circle, and we return it from our make arc path method. Now we need to populate the path property on CA shape layer. And a great place to do this is also layout subviews method, because we are working with bounds. We need those bounds to be set. So right here, I am populating the path property with our method, in which I'm going to pass the center of our lower circle layer as a arc center, which results into this. So far, this is the visual result. Now for the next step, we need to add the gradient donut. And the strategy is kind of different here because we cannot really have a gradient with a donutty shape out of the box, and we cannot have donut shape with gradient fill out of the box. So what we do is we create gradient square with the use of CA gradient layer, which is a subclass of CA layer optimized to do gradient drawing. Then we're gonna create shape of a donut with CA shape layer, which we already know how to do. And finally, we will mask the gradient with the shape. So let's do this. First of all, I will create CA gradient layer and I'll configure it. Here, I'm only populating the colors property, and this property accepts an array of CG color. And be careful here, because if I were to pass a UI color, then the drawing would silently fail. And that's a common problem in working with CoreAnimation. The compiler doesn't tell you anything, and you don't see on the screen what you expect to see. So you have to figure out on your own what's wrong. So this is our sublayer CA gradient layer. Then we add the layer to the layout as a part of init, setupLayout, and I'm adding it as a second sublayer. So it is above the lower circle layer in the visual hierarchy. And finally, we manage size and position in layout subviews. So here I'm setting the frame of the gradient layer to be equal to the bounds of the view. So it fills the whole bounds of our view. So this is our class so far. Here I'm declaring gradient layer, I'm adding it to layout, and finally I'm managing size and position. And this is what we get. Now we need to create a shape that we're going to use to mask the gradient. So I will add yet another sublayer, which is called gradient mask layer. And it is also a shape layer. And as you can see, these two top layers are identical. So I can create a little factory method and initialize both of them like this. Now we need to add the mask to the layout. And this is a bit different because when we add mask to the layout, we don't really add it as a sublayer, but instead we add it as a mask property of the layer which we want to mask it with. So we add it like this, and now the gradient mask layer lives in the coordinate space of gradient layer. So finally, I manage size and position and shape in layout subviews. So here I'm setting the path property of gradient mask layer. I'm populating it with our method, which creates CGPath. And the arc center which I'm passing is the center of the coordinate system in which the masking layer lives. So gradient layer bounds center. And this is what we get. This is all our class. So just to recap, here we are declaring, configuring all of our sublayers. Then we need to add them to layout once. And finally, we manage size and position in layout subviews. So that's drawing, that's done. Do you have any questions so far? Okay, maybe I have a question. Do you have experience with creating UI views with custom draw content like this? And if you do you take similar approach? Or is your approach totally different? And do you see something in my code that I shouldn't be doing, or something that should be there and it's not? Nice. Cool, so we can move on next to the animation. And there's a little poll for you. Okay. Nice. So I can see I'm not totally off the road, totally different. Okay. I would be interested in what is totally different.
We have a question in the chat. And the question is if the circle is being drawn twice.
Mm-hmm. Well, there is a property, I think, on layer which you can set. I don't really remember the name, but it basically says that if it's true, then the layer would only be drawn once. So if you do not need the layer to be drawn multiple times, then that's the way to go for you. But if you are planning to move the view around then, or make some changes to the layer, that's probably something not that you want. Okay.
And we have one more question that I think we can cover now. Yerzy is asking if you've considered or have experience with the Lottie framework.
Lottie framework, yes, we've considered it, and actually it's not really ideal for us, because when we do this sort of UI elements, the use case usually is that we have to move them around and do all sorts of kind of dynamic kind of operations from them. So let's say based on the user gameplay, one time some sort of target appears on the left screen and moves from the right to the left and then shrinks. And then in other scenarios, it does something totally different. And in my opinion, Lottie was more kind of for static animations, but I know there is some sort of dynamic parameter and you can customize this a bit, but I haven't looked into it more. So that's why we use CoreAnimation for this.
Yeah, I think also for your case, it would be difficult to work with designers because every time the animation would change, they would have to export it again from Adobe After Effects, I believe.
That's a good point. Yeah. Okay, so let's move on to animation. And as I said before, you can use UI view APIs to do some animation. You can animate something by UI view.animate with duration, something. But let's say we want to use CoreAnimation directly, so we can have more power and flexibility. And in order to do this, we will follow this approach, which is we will create animation object in which we specify the name of the property which we are trying to animate. Then we will configure this animation object, which means setting duration, start value, end value, timing function, whatever you want. And finally, we will add this animation object to the layer which we want to animate. And this instantly triggers the animation. And what is the property that we want to animate? If you remember, we defined the path for our gradient circle as a donut, right? As a circle which started at 12 o'clock and then it went around 360 degrees anti-clockwise and ended back again at 12 o'clock. And by doing this, we should understand that there is a concept of a stroke existing in iOS similarly that it is in real life. Meaning that if you were to draw a straight line in real life, you wouldn't just go poof and there's a straight line. You would start by putting your pen on a piece of paper in some point, and then you would start to stroke a path to some other point, and then you would reach that point, and then you have a path. Then you have a straight line, sorry. So similarly, the drawing in iOS gets drawn. And by setting the path, we are setting the path that should be stroked during the drawing. But we don't have to stroke it all the way. So in make shape layer method, in which I'm initializing our CA shape layer, I'm adding some properties, which is stroke start and stroke end. And these are like nominal values, meaning it's 100% and 0%. And this is how our object looks like when we stroke the path the whole way from the start 0 to end 1, which is all the way. And this is how it looks like when we set the stroke end to be 0.5. So the path of a full circle is still there, but we only stroke it the halfway. And this is the property that we want to animate. We want to animate the stroke end property from value 1, which is full gradient circle, to value 0, which is non-circle at all. So let's do this. I will create animate method in which I will follow the three-step approach. First, I will create an animation object. This is an object of type C8 basic animation. And here I am defining the name of the property which I am trying to animate, stroke end. And if this is misspelled, the animation will again silently fail. Number 2, I will configure the animation object. I will set duration. I will set repeat count to be only once. And I want to go with stroke end from value 1 to value 0. And finally, I will add the animation object to the layer, which triggers the animation instantly. So it looks like this. Now, if you notice, that in the very moment the gradient disappears fully, the color comes back again instantly. And let's say we do not want to do this. Let's say that we want the behavior to be, once the gradient layer disappears, we want it to stay disappeared. And for this, we need to understand the concept of a layer tree. So animation application, which uses CoreAnimation, maintains a three parallel hierarchies for your visual object. And your visual object has a representation in each of these parallel hierarchies. Each hierarchy has a specific role in making your content appear on the screen. Now, these are model layer, or just layer, presentation layer, and render layer. And render layer here is red because it is private to CoreAnimation and you don't get to touch it in your code. The model layer, that's the one you are most familiar with from your code. When you change something on your layer, just like alpha or corner radius, that's you updating model layer. So it's static representation of your visual object. Presentation layer is what you see when there are animations running. So here in model layer, we can see our big donut, right? This is how we draw it. And once we add the animation to the layer, which triggers the animation, we see this. In the presentation layer, we see the animation, and just as it finishes, it gets removed from the layer, and we are back at seeing the model layer, which looks like this still. So if you want your model layer to match the last frame of your animation, you need to sync them up. And a common practice is to do this right before we add the animation object to the layer. So right here, I am setting gradient mask layer to the stroke end equals 0. So when the animate method is called, we are starting to animate the stroke end from value 1 to value 0, but behind the curtains, the model layer is already set with stroke end 0, but we don't see the model layer. We are seeing the presentation layer with animation. And once the animation is done, it gets removed, and we see the model layer with stroke end 0, which equals to this. And you can do lots of different things with CoreAnimation APIs to do the animation. You can do different grouping of animation. You can do key path and keyframe animations. You can run them sequentially or in parallel. It's a very strong tool. But for us, we reached the moment where it kind of wasn't enough. And this is the functionality that triggered not enough kind of mindset. So the idea here is that during the game, there is the state where a player is supposed to drag the target across the goal. And when he releases the target, the kind of a skill game starts. And skill game is this pulsing circle, which goes from big to small, and player is supposed to click the game button and stop it at the very smallest. So this is the target. He drags it, he releases it, skill game, stop. This is the animation. And particular part of this animation is this. There is like a dot indicator which keeps rotating around the pulsing circle. And two things are happening here. One is that the dot is changing distance to the center of the circle, and the other is that the dot is changing angle, it's rotating around. So it's kind of creating this spiraling movement. And I thought that, okay, we have CoreAnimation. I can do this with combining two animations, which one would be the animation of a path of this shape layer from a maximum, from the biggest circle to the smallest circle on the straight line, and the other would be the animation of the rotation. However, due to some limitations in CoreAnimation framework, this wouldn't really work as I expected, which led to our next approach to animating, which is timer-based animation using CADisplayLink. So CADisplayLink is a special timer, which is provided for you by CoreAnimation again. And what it does is that it gives you a little push, a little callback every time the screen is about to be refreshed. And you can do whatever you want with this. And in order to turn it into the animation, we need to do a couple of things. So let's say I want to animate with CADisplayLink this dot, and I want to animate the movement from left to right. We will be only animating the coordinate X. So in order to do this, we need to first set the duration of the animation. So let's say it's 10 seconds in total. Then we need to set the start value and end value of the property which we are trying to animate, which is the X coordinate. So start value is 0, end value is 10. Then we need to start the animation. So at the very beginning, we know that we are at the second 0, and we should be at the position X equals 0. And now the CADisplayLink magic comes in. So every time CADisplayLink triggers, and CADisplayLink is very fast, meaning that it will trigger many times per second. But for the sake of the presentation, let's say it triggers once every second. So every time it gives you a little callback, we need to first calculate the current time point of animation. CADisplayLink comes with a little timestamp. So when we get callback, we actually can determine, okay, we are now at the first second of our animation. And that's first second of 10 seconds in total, which means that we can calculate the progress. And this gear sign, that's a sign for progress. And so we know now we are at the 10% of animation, and screen is about to be refreshed. So what do we do is that we use this progress value to calculate the value of animated property for the next frame, for the next screen refresh. And we do this by end value minus the starting value, which is 10 minus 0 times the progress, which equals 1. So now we know that at 10% of the animation, the position of X should be 1, and we update the model layer directly. This is what we do. And this is the main difference as opposed to when working with UI view animations or CoreAnimation's API, because in those frameworks, you get these interpolating values between start value and end value for free, right? You only said, I want to go from opacity 0 to opacity 100, and you don't care. But with CADisplayLink, you have to manually calculate for each frame what is the value that should be displayed on the screen. And this is the idea of CADisplayLink animation. So you get these callbacks during animation, right? You calculate progress, and based on this progress, you calculate the value of animated property, and you update the model layer in real time. And as you can see, the callbacks are kind of proportionally distributed across the duration of the animation, meaning the progress, which we calculate from the callback, is also proportional. So we will get progress 10%, 20%, 30, 40, 50. And the animation which we will create is also proportional, linear. And let's say if we want to use some sort of other timing function like ease in or ease out, in order to do this, we need to run the calculated progress, which is proportional, through some sort of interpolation function, which gives us adjusted value of progress, and we use this adjusted value to calculate the value of animated property, which creates the animation with timing function other than linear. And again, if you were with CoreAnimation, you get timing functions for free, but when you use CADisplayLink, you have to calculate the interpolation by yourself, which can be pain. So now I would like to demonstrate how to animate something like this, which is a movement of this red dot from left to right with CADisplayLink. So we just get a little feel of it, how it looks in the code. So first of all, I will create a custom UI view class, and in it, I'm doing things that we already know. Here, I'm declaring my CA shape layer, which will represent my red dot. I will add it to layout. And finally, I manage size and position and shape in layout subviews. So this is what we have. Now for the CADisplayLink code. In our class, I will add CADisplayLink, which is an optional reference to CADisplayLink object. And that's because CADisplayLink only needs to be alive once while it is producing callbacks. So we will instantiate it later on. And then we have some animation values like starting value of X, which is like the very left of our view, and the end value, which is the very right of our view, and the duration. Now, in order to start the animation, we will call startDisplayLink method, which first will invalidate any already existing display link. And this is an approach that we can see from working with timers. And CADisplayLink is sort of a timer, so it's okay to do this. And now we want to instantiate the DisplayLink object, which, if you see, kind of resembles this target action kind of pattern. And what we are doing here is basically saying create object of type CADisplayLink, and every time it triggers, every time the screen is about to be refreshed, call method handle DisplayLink on the target, which is self. Now we get the object, and if we want to start getting callbacks from it, we need to add it to the run loop, which is a object which is handling this timer-based events. So we add it to the run loop, and immediately we start getting callbacks. And for each callback, handle DisplayLink method is called. So here we use DisplayLink. We use the time step to calculate the progress. We calculate the value of animated property, and we update the property in real time, which creates the animation. So this is our class. Now, word of caution. Every time the CADisplayLink triggers and you are updating some sort of property, if you are updating some property on CoreAnimation layer, on CA layer, the default behavior is that if you change the value of the property after the initialization, the change will be animated for you by default for free with CoreAnimation. So let's say our view has been created, and after 3 seconds, I decide I will change the property position on my CA shape layer. So this is what happens. See, it gets animated for free. And this is something that you might not want to do, because you are doing the hard work, you are calculating all those interpolating values, and you want to do the animation by yourself. So you don't want any implicit default animations from CoreAnimation, because you would get some sort of unexpected behavior. So the way to go here is to disable this behavior. And there are different strategies how to do this. And one of them is you can trigger the change. You can trigger the change as a CA transaction which disabled animation, which is like this package of instructions which you send to a render with a big flag, do not animate. And this is what happens. Okay, so this is CADisplayLink animation, and it has many pluses for us, because if you remember this kind of feature, right? The behavior is that in the moment the user clicks the button, all of the animations on the screen should stop immediately where they are, right? And if we were to use CoreAnimation, that would mean that in the moment the user clicks, we have to first sync up all of the model layers with the last frame of the any running animations in our layers, and then we need to remove all of those animations. But now, since we are using CADisplayLink, we do not have to care about this because we are updating the model layer in real time. So that's a great plus for us. Now, on live penalty, we are trying to make life a bit easier, so we don't have to write the CADisplayLink code all the time. And we are trying to turn this into a little framework, which is inspired by how Android approaches their animation. And it's basically a big copy of how they do it. And in the center, there is this animator object, which knows about the screen refresh rate. It uses CADisplayLink. It knows about the duration of the animation, so it can calculate progress for you. And it has some control methods like start, cancel, and it gives you callbacks. So you know when the animation has started, when it will update, when it ended. And what you do is that you do not use this animator object directly, but you create a child class of animator, which is a value specific animator, which needs to specify the start and end value of animated property, and then calculate the value of animated property from progress. And this is because you can animate many things in iOS. You can animate color and distance, and you can animate many things. And each of those things, each different data type might require different way how to use progress to calculate the interpolating value between start value and end value. So in the end, you would have like a color animator, and you would have CG float animator, and each of these can use the progress value their own way for their own needs. And similarly, in the app, we have something easy like a CG float value animator, which does exactly this, just calculate interpolating values between start value and final value. And then we have a color animator, which needs to use the progress somehow different, right? Or you can create these more complex animators, like this spiraling animator, which solves the problem of the spiraling dot around the closing circle. And these are all declarations. So when you need to do the animation, you actually first in some method you will create the animator object, right? Where you pass in some start value and end value and duration. And then you will say that every time the color animation updates means every time color animation will compute the value of your animated property, you will use that value to update your model layer in real time. And that's it. And finally, I will set color animator start, and the animation gets done. And also the part of the framework is like this animator set object, which can group the animators together, and it can play them either in sequence or in parallel. So this is kind of approach that we are taking nowadays. And we are still sometimes going back to core animation, but sometimes this approach gives us much more power and flexibility, so we use that. And also, if you animate something with core animation, and let's say you are in the middle of animation and you leave the screen, then the animation gets removed. But let's say you want the visual state of that animation to stay on the screen right after you come back. And there are ways how you can do that with core animation, but it's painful. And with this approach, with CADisplayLink, you don't need to worry, because you updated the model layer, you leave the screen, you come back, and it's still there because you updated the model layer. And this is kind of all that I wanted to talk to you about today. I hope you could stay on track. I hope it wasn't confusing. And if you have any questions, please shoot.
Thank you, Peter. We have so far one more question in the Q&A, but maybe there will be more, and maybe there are some on YouTube. So I will start with this one. The question is, if you know of some like high-level animation frameworks, since core animation is fairly low-level framework.
Well, you can think of as UI view APIs as a framework above the core animation, right? It accesses core animation for you, and you can do most of the basic things, but once you want to do something really specific, you can't. And otherwise than that, I don't really have experience with anything different.
Mm-hmm. Well, there's the Lottie that was already mentioned, and there is also Hero, which is a framework for mainly custom transition between controllers, and yeah, those are, I think, the major ones.
Yeah, and you can try to use SpriteKit or something like that for games, but SpriteKit is also a physics engine. So if you don't really need things colliding in your application, maybe that's not what you really want. And plus that we are developing the application both on iOS and on Android. So if we were to move into some more robust animation framework, it would probably be Unity. So we can implement the one solution and it would work for both platforms.
Mm-hmm. There is a question. Well, it's not really a question, but there is a comment that it was awesome, and that Pavel Minarik have used CADisplayLink as well, and he was surprised by its existence, and he thinks that Apple should promote it more.
Same here.
There is one more question. How would you set other than this linear progress? Do you need to compute it for every linear update, or you can set other than linear progress update?
Well, let's say that you get the callback and you calculate the progress, which is linear, right? Let's say it's 10%. And now you need that function which does the math for you. And as I was browsing in some Android repository, I did find like functions for the basic timing function. So you can have your ease in, ease out and stuff like that. But if you want to do some other timing function, which is defined by a Bezier curve, which are like 4 different points, and you would need to use some sort of Newton method or something like this, or you would need, I didn't find anything on the internet.
So basically there are some basic built-in functions, and the rest you have to compute on yourself, right?
Yeah, but even the basic ones you have to get somewhere from the internet if you are using CADisplayLink.
Mm-hmm. And there is one more question. Have you ever had to animate path from CA shape layers also in Live Penalty?
Yes. Actually, that was the first thought I had when I had to animate the animation of spiraling gulichka, the spiraling dot around the circle. I thought that I could animate the path of that dot with together with animation of rotation, but it wouldn't work. But yes, you can do that, definitely. But I think maybe you can't really use CA basic animation for that, but instead you have to create a keyframe object animation, which allows you to do that.
Also in SwiftUI, there's a decent support for vector animations.
Mm-hmm.
That might be a good option too for some cases. Do we have any more questions from the audience? You can also raise your hand and ask Peter directly. He doesn't bite.
How do you know?
Sometimes, most of the time. I guess there are no more questions. Thank you, Peter, for the awesome presentation. Thank you, everyone, for attending. We will share with you a feedback form. So if you'd like to share your feedback with us, we would really appreciate that. And also we might share with you some interesting links and presentation slides as well after the presentation. Annette, did we forget about something?
No, I think if there are no questions, there are no more questions. I would just like to thank you for participation and also to our speakers for a great event. The next event will be in 2 weeks, and it will be an Android talk where Juraj Kuliška will be talking about Android testing monster debunked. So if you don't want to miss that, register on the Eventbrite or check out the events section on our website. And since we want to be proud of everything we do at STRV, we want our events to be the best. This is why we would really appreciate your feedback through the survey, which will be open right after the end of this event. And that's it. Thank you very much, everyone, and have a nice day.